Design for Manufacture and Assembly, or DFMA for short, is a process which takes a design-led approach to construction, encompassing a wide spectrum of tools and technologies to design and assemble buildings in a more resource-efficient and cost-effective way. Central to the DFMA approach is the greater use of off-site manufacturing, minimizing the need for on-site bespoke construction due to the significant advantages associated with manufacturing in a controlled factory environment. A DFMA-based approach requires designers to think in a holistic way about buildings, and not only about the technical design of a project, but also about how it will be made, assembled, and importantly, how quality and performance can be guaranteed in real life. DFMA also requires increased collaboration across the value chain between design teams, clients, contractors, and off-site manufacturers. Significantly, from a design perspective, DFMA offers designers the opportunity to standardize some aspects of a project, providing additional time to focus efforts in areas where real value can be added. DFMA encompasses many techniques which include volumetric approaches, creating as much of a finished product as possible in a factory, minimizing on-site labor as much as possible. Flat pack solutions, providing a kit of parts which can be quickly and efficiently assembled on site. Prefabricated sub-assemblies, which can be installed along with more traditional elements with similar effects to more complete prefabricated systems. Please now click the link to find out a little more about DFMA from Rob Francis, Director of Business Innovation and Development from Skanska.
DFMA is not just about what we're designing, it's about how we're going to implement the project. And also we'll gain efficiencies by standardising some of the design, and by standardising design we also then trigger economies of scale all the way through the supply chain, and then once again we drive efficiencies through those economies of scale. The DFMA approach really links into being efficient with material deliveries, being efficient with material storages, and also minimising packaging and waste, and therefore the amount of skips you have to take away from sites. And finally for me, and probably the most important, at the earliest possible stage with the DFMA approach, we can also look at designing for safety. A really important issue, particularly for Skanska. It's one of our major priorities, and we can design out potential risks, we can design out potential difficult processes and mitigate those at the earliest possible stage.
Now you know a little bit more about what DFMA is. Why is it so important? As a bit of background, the UK government's 2025 construction strategy has set the industry targets to deliver projects 50% faster, with 50% less carbon emissions and 33% lower costs. In addition, the government has set targets for the construction of 1 million new homes by 2020. That's 250,000 per year. So we need to up our efforts a bit. Now set that against a context where there has been no productivity gains in the UK construction industry for the last 30 years, and it is therefore fair to assume that there is widespread consensus that it will be very difficult for the construction sector to meet these targets if business continues as normal. What is needed is a more efficient method of construction, which results in the completion of more sustainable buildings in less time, to a higher quality standard, more safely, and at a reduced cost. The fact is that the evidence is out there, which suggests that if we do adopt a DFMA-based approach, then these targets might just be achievable. Please now click on the icons below to find out more about the key advantages of DFMA. DFMA reduces health and safety risks in a number of ways. During construction, plant and machinery movements and the need to carry out complex tasks may be reduced. The need for working at heights can be very much reduced, and in addition, the overall construction time will be reduced, decreasing the chance of accidents. Time. A key benefit of DFMA is a significant reduction in the time taken during the on-site construction phase of between 20 and 60%. Whilst design time actually increases, the overall effect is to reduce project timescales. Perhaps more importantly, a DFMA approach allows greater program certainty and reduces the risk of time overruns and delays through increased use of standardized components. Cost. DFMA makes design and construction more efficient. Significant reductions in the time taken to construct and waste generated, and more productive working practices, which ultimately lead to cost savings. Labour and skills. At present, there are significant skills shortages in the construction sector. And from an on-site perspective, DFMA can reduce on-site labour requirements by 70%, also reducing their skills gap. Equally, DFMA will provide new opportunities for multi-skilled operatives working both on-site and in a factory environment. Work patterns associated with factory working will also attract new and more diverse talent into the industry. Please now click the link to hear from Rob Francis from Skanska, giving a main contractor's perspective on skills and DFMA.
On many companies and projects that we're currently delivering. In terms of DFMA and how it can help with that sort of skills shortage across the industry, by getting into a DFMA approach right at the start of the process and being able to design the project in a more logical way and a more assembled fashion rather than constructed fashion, we can therefore build some of those elements of the project off-site in a factory remote so we can ship it in. And that actually lessens the impact of the skills we require on-site. Of course we still need electricians and some of the skilled trades still on-site, but it'll be far less dependent upon those guys on-site. We can go to the manufacturing facilities and manufacturing supply chain and drive our efficiencies and workforce through the off-site approach.
Manufacturing in a factory environment enables components and sub-assemblies to be built more consistently to finer tolerances, improving quality and performance. This reduces snagging and means that a building will perform to its designed performance.
If you buy a car and the doors don't work, you would send it back because the doors don't work. If you buy a building and the doors don't work, people tend to say, that's construction for you. So there's levels of quality control that you would inherently expect in a manufactured product. There's no reason you can't achieve that level of quality on site. So all of the things you can do away from site around quality inspections, pre-commissioning, pre-testing, all of those things should result in a better quality, more precisely engineered element in the first place. We're also finding that because you're thinking about everything long before it gets on site, things that might be made up on site traditionally, so the final position of valves, screws and things, thinking about that earlier tends to result in really considering all the maintenance aspects of buildings, so we don't find clashes that happen on site or things we didn't think about that only get discovered on site because you've done all the forward thinking. Because you've made saving elsewhere in terms of logistics, people, waste, you can afford to get a better quality, higher quality material that has a longer term usefulness. So we have buildings we've done at the airport where they've had to replace the floor because they get an awful lot of footfall, but the internal lining, we used folded metal panels instead of plasterboard. They're incredibly resilient, they're very precisely engineered, they still look fantastic. And the same in hospitals, we found that we can use really nice, very high specification materials in a particular way that just inherently gives you a very long-term life of the building.
From a sustainability perspective, DFMA can really improve the efficiency of construction and the efficiency of the way that you do things. From a design perspective, you standardise certain components. When you think about a contractor on site, they can build a building more quickly. If you're a consumer, then the building is going to perform to its standard specifications. So, real key issue at the moment within the construction sector is the performance gap. you have a building that's designed to perform in a certain way, but because of hundreds of maybe tiny little deviations on that design that happen when you're working on site, and things don't quite fit together properly. If it's a Friday afternoon and it's raining and you don't put a piece of insulation in, then it can have a real impact on how a building works. In a factory, you don't get a rainy afternoon on a Friday and you can standardise your product. This has loads of other sustainability benefits. It means that your carbon emissions are reduced, it reduces your energy bills, and from a community perspective, if you have a building that's being built with less waste in less time to a higher standard, then it means that from the lorries driving through your town, that there might be less of them because there's less deliveries to site. That's obviously a disturbance issue, but there's also an air quality issue involved with that. When you think about the construction of the building itself, there's less disturbance from noise. At the end of it, you get a building which is at a higher quality and potentially better within the actual kind of confines of your community as well. So by taking this approach, you really can improve the sustainability of the finished product in the building that you produce.